In section 7.2, we're going to do the same thing we did in section 7.1. We're going to create confidence intervals, except for this time, instead of creating a confidence interval for a proportion, that's what we did in 7.1, we focus in on confidence intervals for proportions. And that's why we did a 1 prop z interval. What we're going to be doing here in section 7.2 is we're going to make a confidence interval for the mean. So we're going to make confidence intervals for the mean. And again, remember we're doing confidence intervals for an entire population. So that's why we used a regular P for proportions. And now we're going to be using, again, population mean. Our special letter is mu. Okay, what we're going to focus in on first is when we actually are going to be given sigma. Well, what is sigma as a reminder? Well, sigma as a reminder is your population standard deviation. Sigma is your population standard deviation. Okay, so if we know our sigma, we're going to do something one way. If we don't know our sigma, we're going to do it another way, but there's still confidence intervals for the mean. That's the only thing that we're looking at in this particular section. So before, when we did our confidence intervals for proportions, we put the p hat in the middle because that was our proportion for the sample. So same idea here. When we build our confidence interval, let's see, and we go to draw our number line. Remember, confidence intervals have two ends. Before we put the p hat in the middle, this time we're going to put, well, what's the symbol for sample mean? Well, for sample mean, remember our symbol is x bar. So, still got like a little type, it's not a hat, but it's similar. We'll put our x bar, mean, in the middle, which is good. We're used to sticking the mean in the middle of things. And then we're going to do exactly what we did for the population proportion, is we took the error, we found it, and we added the error to get the top end value. And then to get the lower end value, we subtracted the error. This time we're just going to be adding and subtracting the error to the mean. That's the only difference. So we'll have a slightly different formula though. So we're going to add the error to the mean to get the top end, and we're going to subtract the error from the mean to get the lower end. And just like before, our sample mean is always in the middle, and this will create our confidence interval for a population mean, mu. And this is going to be a setup whether we have sigma or not. What's going to vary is actually how you find your error. That's what's going to vary from problem to problem, whether or not you have sigma or not. Okay, so let's look. There's two different formulas for error. The first error formula that we'll look at has z's in it. It has a z sub c, which is it's our critical value. We've talked about that before. And then it has sigma in it, our population standard deviation, and then has u dividing by the square root of n. So obviously, because they actually used sigma in the formula, this is the formula we're going to actually use if they give us the population standard deviation, if they give us sigma. So if we know sigma, we're going to use this first formula. So if sigma is known, if they give us the population standard deviation in the actual problem, we're going to use this first formula to find the error. However, what if they don't give us the population standard deviation? Well, they still are going to give us a standard deviation. It just won't be the population standard deviation. So if it's not a population standard deviation, it will be a sample standard deviation. So it'll be an S. So if we don't have sigma, then we'll have S. And we'll use this second formula. And remember, S stands for your sample standard deviation. Now, you should be noticing the square root of n is still the same. Still on the bottom. There is one subtle difference. And it's a pretty big one. And it's now that we have a t instead of a z. So this is going to be new. Whenever we don't have sigma, we're going to be using t's as well. So there is going to be a part of your calculator that's going to have t's now. And again, it's going to be pretty straightforward. If you have sigma, you're going to use the formula with z's. If you don't have sigma, you're going to use the formula with t's. So I always think of this as kind of like a flow chart. If we have sigma, you're going to go one way. If you don't have sigma, you go another way. So if you have sigma, you're going to use z's. If you don't have sigma, you're going to use t's. And you can kind of use that as a good rule of thumb that will always work. Now, what's awesome about the t values is they work almost exactly like the z values. It still looks like the same curve. It's still a normal distribution, bell curve, just like this. So what's the difference is your numbers will be slightly different. So if you do these problems wrong and use z's instead of t's or t's instead of z's, what'll happen is you'll get an answer that looks super close to the correct answer but isn't right. And then you'll have to go read your problem and say, oops, I used z's when I should have used t's, or vice versa. So there is this new thing that we're doing now that's called t's. And so what we call it is it's called a t distribution. So for z's, we actually call it the normal distribution. And now we've got t's, and we're going to call that the t distribution. And they look super, super similar. So they both have your bell shape. They're both symmetric. They both are based on the mean. It's just with the mean being in the middle, it's just whether or not you have sigma. That is really the only thing we care about. If you know sigma, you're going to use your z's. If you don't know sigma, you're going to use your t's. And it will be that way through chapter 7 and chapters 8. So you do need to remember this. So just like before what we've done in previous sections, we're going to have our calculator do as much of the heavy lifting as we can to make these confidence intervals. But the idea will be the same no matter if we're using z's or t's. For confidence intervals for the mean, we build our confidence interval no matter what with the mean in the middle, and we'll come up with our upper end by adding an error, and we will come up with our lower end by taking the mean and subtracting the error. The only thing that's going to vary is the actual formula for the error, and it's all based on whether or not we have a population standard deviation or a sample standard deviation.